Hi guys, welcome back to another video. The topic for today is combinatorics. Okay, combinatorics is basically counting, permutation and combination, a mixture of counting, permutation and combination. Okay, we'll learn this topic in three parts. Okay, one for counting, one for permutation, one combination. See, the biggest challenge that students face from this topic is the calculations are easy. Okay, the problem comes what to apply when. Okay, because since there is a lot of intermingling that happens here, okay, we are not sure. Okay, in this question, should I apply permutation, should I apply combination? Okay, I apply combination, but when I see the solution, it's done with permutation. Next time I apply permutation, now I see the solution, it's done with combination, right? So there is a lot of confusion that happens because of that, right? So what we are going to learn in these videos is how to segregate the question from permutation, combination and counting. Okay, remember, in this topic calculation is not a problem. Okay, the challenge is to understand what concept to apply. Okay, so if you are able to understand whether you need to apply counting, permutation or combination, 25% of the question is solved then and there itself. Okay, then it comes to, okay, how do I apply it, and then the calculation part. Okay, so the mental solving of the problems is 50% of your challenge. Okay, if you are able to solve it, or if you are able to categorize it and understand it, okay, you have solved 50% of the questions there itself. Then you just have to calculate and get the answer. Alright, so without further ado, let's understand combinatorics, let's understand counting, permutation, combination, the differences between them, when to apply what. Okay, alright. Now, focus for today is going to be counting. Okay, the focus for today is going to be on counting. Okay, counting means your simple cases, right? You make spaces, you write down how many options are there, you either multiply or add to get to the answer. Okay, in case of counting, what we are doing, we are just literally counting options. Okay, we are literally counting options for each case. Okay, we are not applying any formula, we are not applying any method, anything. We are literally counting options for each and every case. Okay, now question comes ki, okay, fine, I understand what is counting. How do I apply it? When do I apply it? Alright, so remember one important thing, right, when we do counting. Okay, one important thing when we do counting is, see, you read the question. Okay, you will read the question, you will ask yourself if repetition is allowed or not. Okay, so we use counting when repetition is allowed, because remember one thing about permutation and combination, they do not allow repetition to happen. Okay, so they don't allow the same thing to repeat again and again. Alright, so whenever you see the question and you understand that, okay, repetition is allowed, repetition of values is allowed, you have to think about counting. Okay, so whenever repetition is allowed, we go for counting, which simply means that whenever repetition is not allowed, okay, whenever repetition is not allowed, then only we will go for permutation or combination. Okay, then only we will go for permutation or combination. Alright, now let's take an example to understand the difference between the three. What do I mean by repetition allowed, not allowed, when to apply, how to apply, right? Alright, so if you read the first example, okay, if you read the first example, it says we have 5 students. Okay, we are awarding a prize to the best performer in quant and verbal. Okay, so there are 5 students. Okay, we want to, what do you say, we want to give a prize to the best performer of quant and verbal. Alright, now question comes, in how many ways can we award the prizes? Now if you think here, say you are one of those students. Okay, interestingly, you guys will also like to understand, or you'll be happy to know that we only take 5 students per batch. Okay, so this could be that you are part of the batch. So we have a batch, 5 students only, right? And say you are one of them. Now we have taken a test. Now just think for yourself, can you win both the prizes? Is it possible that you win the quant, like prize in quant test, and you also win the prize for verbal test? Right? The answer to that is yes. The same person can win both the prizes. So this is what is called repetition allowed. Okay, this is what is called repetition allowed. Okay, when the same person can win both the prizes or same value can repeat again and again, this is what is called repetition allowed. So then what do? We simply make spaces. These are the options. Okay, these are the options for people who can be awarded a prize for quant test. These are the number of people, okay, or options for verbal test. Now, for quant test, how many options do I have? 5. Any one of the 5 students can get the quant prize. Similarly, for verbal, again we have 5 options because any one of the 5 again can win those prizes. And since I want this and this, right? So total cases become 5 into 5, that's 25. Okay, total cases become 5 into 5, that's 25. Okay, so this is what we understand from repetition allowed. Okay, the question will not come, sometimes they do, but question won't come and tell you that repetition is allowed. You have to think. Okay, before you jump into solving the question, just take a step back, think, is repetition allowed? Can the same person or value or variable repeat again and again? If the answer to that is yes, then you say repetition is allowed. I will directly do counting. I'll apply the method of counting to solve the questions. Alright, now let's read the second one. So it says again same 5 students. Okay, we are awarding 2 prizes, 1 gold, 1 silver. Okay, we are awarding 2 prizes and there is only one test, say quant test. Okay, how many ways can we award the prizes? Alright, so now think, 5 students in a batch, we are conducting a quant test, we will give prize to the top 2 performers. Top one will obviously get gold, second one will get silver. Now think, can you as a student win both the prizes? Can you get gold also and silver also? So the answer to that is no, right? Because if you win gold, somebody else will get silver. If you get silver, somebody else will get gold, right? So the answer to that is no. So here we say repetition is not allowed. Okay, here we say repetition is not allowed. So then we don't go for counting. Okay, then what do we go for? So we think, okay, does the order matter? Okay, does the order matter? Right, who comes first, who comes second? So we say yes, the order matter here because the first one will get gold, the second one will get silver. So then we apply permutation. Because order matters, okay, we apply permutation. We have 5 options. We need to give 2 prizes to 2 people. So answer becomes 5p2. Again, you do not have to worry. We will look at permutation in much more detail in the next video. Okay, today the focus is only on counting. All right, I hope you understand the difference between the two. Okay, if you do, let's look at the third one. Again, if you see, we have 5 students. Okay, we are giving the same chocolate to the top 2 performers. So now what is the difference? Again, there are 5 students in the batch. Okay, again there is a quant test that is being conducted. We are giving prize to top 2 performers, but we are giving the same prize. Now you think, can repetition happen? Again the answer is no, right? Because if you win, if you are the first one, you can't be the second one, right? So again the answer is no. So repetition allowed, answer is no. Now, does the order matter? No, because irrespective of you come first or second, you are getting the same chocolate. So how does it matter, right? So then we say order matters, answer is no. So if repetition is or not allowed, order also does not matter. That is when we use combination. Okay, so we have 5C2, right, which is 10. Again, how do we solve that and all? That will come as part 3 of the video. Okay, so today we focus on counting. I hope you understand the difference between the 3. Okay, with these examples, I hope you understand. Alright, so let's quickly recap what is counting, when do we use it. So remember, in your mind, make this table. Okay, question number 1, after reading the question, is repetition allowed or not? Okay, repetition allowed. If the answer to that is yes, you will use counting. Okay, If the answer to that is yes, don't think in terms of permutation combination, think in terms of counting. If the answer to this is no, then you think, okay, fine, answer to this is no, then you think order matters, the order in which things are happening. Does the order matter? Again, if the answer is yes, then you say we will use permutation. Okay, if the answer to this is no, then you tell yourself I will use combination. Okay, pardon my handwriting, right? The point is, if you do this exercise, mental exercise, for 10 or 15 seconds after reading the question, trust me, you will never make any mistake. Okay, you would have compartmentalized the question into different categories. You will know what to do in the question. Okay, so again, repetition allowed, yes, think of counting, don't think of permutation combination at all. Repetition is not allowed, don't think of counting, think only in terms of permutation combination. Okay, let's apply the concept in multiple questions to understand how this works. Now, one last thing before we jump to questions. So when you are doing counting, you know you are going to make spaces, right? You are going to write the options in those spaces. But then another question comes, what do I do? Do I multiply? Do I add? Okay, what do I do and how do I decide? So remember, for multiplication and addition, the concept or the differentiation is very simple. If you are using the word and, okay, you multiply. If you are using the word or, you add. Okay, let's take an example to understand this. Say we want numbers, okay, numbers less than 100. Okay, we want numbers less than 100. Okay, and we want the numbers to be even. Okay, we want the numbers to be even. So now when you say less than 100, okay, and say these are positive numbers. Okay, these are positive numbers. So the first thing that should come to your mind is I can have either single digit or, right, or two digit numbers. Okay, the first thing you should think is, here what can I have? I can have either a single digit, one digit number, or a two digit number. Okay, single digit means single space will come, two digit means this and this, two digits will come, right? So now if we try and see, we want a single digit number, it has to be even and positive. So there are four options, right? The four options are 2, 4, 6, 8. Okay, cannot be 0 because we want positive. Now when I say two digit number, this is my units digit and this is my tens digit, and means multiplication. Since I want even number, the last digit, there are 5 options. I can have 0, 2, 4, 6, 8. Initial, the beginning digit can be 9 options, 1 to 9, right? These are 9 options, 1 to 9, cannot start with 0. Last digit, okay, last digit has to be even, so that's 0, 2, 4, 6, 8. And since I want this and this both to give me a 2 digit number, we are using multiplication. Now I want one digit or two digit, so one digit or two digit. So the answer becomes one digit or two digit. So that's 49 numbers. Okay, these are 49 numbers. Okay, I hope that makes sense. If you've read the question, okay, let's again work it out. So we have, he can be assigned to any one of the 6 projects. So there are total 6 projects that are going on. He can be assigned to any one of them, right? And he has 4 shifts. So he is planning to work 4 shifts. Okay, and we need to know how many different possible schedules are there. All right. Now before you jump to question, before you directly apply permutation, combination or counting, just think. Okay, say you are Arjun, right? Say you are Arjun. Okay, so there are 6 possible projects that you could work on. Next week you are planning to work on 4 shifts. So just think, can the shifts repeat? Say the shifts be working, say, in mines, working in chemistry lab, physics lab, bio lab, different labs, right? Can the same lab be repeated? Can you work on physics again and again, in a physics lab again and again, or a chemistry lab again and again? Right? If you just read the question, that is possible, because they don't say that the labs can't repeat. So I can do multiple shifts on the same lab also. So by reading this question and thinking about it, I understand that repetition is allowed. Now the moment repetition is allowed, now I say, okay, I will use counting. Okay, I will use counting. So how many shifts are there? 4. 1, 2, 3, 4. And I need to work here and work here and work here and work here. So that is why multiplication. Now for shift 1, how many choices do I have? 6 projects. For shift 2, again 6 projects. Shift 3, again 6 projects. Shift 4, again 6 projects. So that is 6 to the power 4. Okay, if you solve it, that is 1296. Okay, 6 to the power 4, which is 1296. Alright. Now again, if you have read the question, you can see the example itself that tells you the digits are repeating. Okay, so a palindrome, what is a palindrome? A number that reads the same forward and backward. Okay, we want even 6-digit palindromes. So the moment I read it, I know repetition is allowed. The example only says so. So what will I do? Counting again. 1, 2, 3, 4, 5, 6. And since I want all of them at once, I want options here and here and here and right. Now palindrome means whatever I write here, the same thing has to repeat. And I want even 6-digit numbers. Okay. So what are the possibilities here? Because whatever comes here, same thing comes here. Even means this has to be even. Right? And since it's a palindrome, whatever comes here, the same digit comes here. And we know you can't start with 0. So you have only 4 options. 2, 4, 6, 8. So we have only 4 options that can come here. Whatever comes here, the same number repeats here. So 4 options there, which means 1 option here. Now, if I look at the tens digit, right? It can be any number because they don't say anything else. So any of the 10 digits can come here. Whatever comes here, same thing comes here. Similarly, hundreds digit, again 10. Whatever comes here, same thing comes here. So total how many options? 400. Now if you have read it, this is similar to what we did just now. See, it says remain unchanged when digits are reversed. This is simply palindrome, right? Because palindrome is one where the digits, right, are repeated, or you look at it in a reversed order, then also the number is seen. This tells you that repetition is allowed. This tells you that repetition is allowed. And since we want number from 100 to 900, we know it's a 3-digit number. We know it's a 3-digit number. Again, what can come in hundreds place? So it has to be between 1 to 8, because see, 9 can't come. You cannot have 919 because that's greater than 900. So we cannot have 919. Alright. So the numbers 1 to 8, anything can come. So 8 options. Whatever comes in hundreds digit comes in units digit because it's a palindrome. Tens digit can be anything. So again, you have 8 into 10 into 1, 80 options. Right? Guys, remember, calculation and solving is not a problem here. Alright? Mentally, you have to understand what to apply. So you should know that, okay, repetition is allowed, counting. solving will become easy. Okay, remember the whole concept of permutation, combination and combinatorics, right? It's 50% mental, 50% calculation. Okay. Alright. So if you see, we have to make a 3-digit code using the digits 0 to 9. Alright. Now you only think, say you have those travel bags, right? Where you have a 3-digit code, okay, which is your say passcode or anything. Think, can you repeat the digits when you are making a passcode? Yes, you can, right? Your password can be something ABCD something 007, right? So the point is the question won't come and tell you repetition is allowed. You have to read and think, right? Think, what am I supposed to do here? I'm supposed to make, right, a 3-digit code, right? I'm supposed to make a 3-digit code. So then can I repeat the digits? Yes, I can. So again, I say repetition is allowed. Since repetition is allowed, I will do counting, right? I'll make my 3 spaces. Okay. Now what are the constraints? The first digits cannot be 0 or 2. Okay. So the first digit cannot be 0 or 2. So it can be any of the other 8. Second digit must be a 2 or 5. So it's definitely a 2 or a 5. The second and third digits cannot be both 2. Okay. So if this is 2, this cannot be 2. Right. So now what do I do? I make cases. Right. I make cases. So what do I say? Yeah, this is too complicated. Let's make 2 separate cases. Case number 1, tens digit is 2 or tens digit is 5, because that is what they say. The second digit is either 2 or 5. So the moment I do or, you know it has to be addition, right? Okay. Now if tens digit is 2, so this is fixed. It has to be 2. I don't have any option. How many options do I have to make numbers using tens digit 2? First digit cannot be 0 or 2. So I have 8 options. Second tens digit is 2. Units digit cannot be 2. So can be one of the remaining 9 options. Or means addition. I can have tens digit as 5. So I have one option, it has to be 5, no other option. Units digit again cannot be 0 or 2, so one of the 8 options. Now units digit can be anything, so 10 options. So this is 72 or means plus 80. 72 plus 80, 152. Okay. So whenever you are doing counting, think logically, write down the sentence that you want. If you are using and, multiplication. If you are using or, then you know there has to be an addition. Again, a very similar question. See, we have 4-digit number and it should contain only even digits. Again, think, by reading the question, can repetition be allowed? Can the number 2224 be allowed? It is a 4-digit number. Yes. All the digits are even. Yes. So again, the question won't say repetition is allowed or not. You have to think and figure out. So again, we can say repetition is allowed. So we will use counting. 4-digit number, make 4 spaces. Only even digits, but again I can't start with 0. So I have 4 options here. Now I can have any of the 5 options. See here, I can have 2, 4, 6, 8. Here I can have 0, 2, 4, 6, 8. Right. So again, if you just solve this, that's 500. Okay. So remember, it's just understand, go through the process. You'll find that okay, the questions are easier. Alright. So now we have numbers 0 to 999 inclusive, right? And have at least one digit that is a 7. Okay, we have one digit that is a 7, right? Again think, from 0 to 999, can you get numbers where digits are repeated? Again the answer is yes. So we know repetition is allowed, so we know we have to use counting, right? Now question comes, I want at least one digit to be a 7. So I can have 1 7, I can have 2 digits as 7, or I can have all the 3 digits as 7. Okay, so an interesting way to look at it is, what will I do? I'll do total numbers. Okay, so 0 to 999 total numbers minus, okay, numbers that do not have 7. So from the total, if I remove all the numbers that do not contain any 7, the leftover numbers will definitely contain a 7. They may contain 1, 2, 3 sevens, right? So instead of solving 1 7, then 2 sevens, then 3 sevens, what are we doing? We are saying, okay, let's find the total numbers minus the numbers that do not contain any 7. Now, when we talk about total numbers, I make 3 cases, right? 3 spaces, alright? I can have 0 to 9 here, 0 to 9 here, 0 to 9 here. Okay, so that's 10 into 10 into 10. That's 1000 options, right? Now, take your time, let that sink in. Okay, you might think that, okay, how can you start a number with 0? Remember, it's 0 to 99. If my first digit is 0, right? Say for example, if my first digit is 0, my second digit say is 2, third digit say is 0 again. This will become 20, right? Which is a 2-digit number which is allowed. Okay, which is a 2-digit number, and that 2-digit number is allowed. Okay, so the reason we are counting 0 here as well is, I am not saying it is a 3-digit number for sure. If 0 comes in the beginning, I will get a 2-digit number, which is okay. If 0 comes in the first 2, say 0 0 and then you pick 7, that's a single digit number, which is again allowed. If you pick 0 everywhere, then 0 0 0, which is 0, which is allowed, because again this is inclusive, right? So instead of breaking it into 3 cases, that okay, what if it is a single digit number or 2-digit number or 3-digit number, I am just taking 3-digit number. I am saying let 0 come in the beginning, no problem. Okay, so total numbers will be 10 into 10 into 10. Okay, minus numbers that do not have 7. Again we will make 3 spaces, let 0 come. If 0 comes, I will get a 2-digit number, which is fine. I do not want 7, so that's 9 into 9 into 9, because 0 to 9 without 7. So the total cases are 1000. Numbers that do not have digit 7 is 729. If I subtract this, that's 271, right? So there are 271 numbers. These could be single digit, these could be 2-digit, these can be 3-digit numbers, right? Which definitely contain at least 1 digit as 7. Okay, I hope you understand this. Alright, moving to the next one. It's an interesting question. So we have 5 rings to be worn in 3 fingers. Again, think about it. If there are 3 fingers and you try to wear a ring, it will repeat, like the fingers will repeat, correct? You can't just have 1 1 1. Where will the other 2 go, right? So again, repetition is allowed. Now one question or one confusion that students have, see, when you try to memorize, some will say 5 to the power 3 or 3 to the power 5. These are the 2 options that you get confused in. Again, understand it, right? Once you understand, you won't have this problem. All right, now let's say, so we have 5 rings and we have 3 fingers. Okay, now take a pause for a moment and think, if this happens in, say, real life, you are somebody who likes to wear rings on your fingers, what will happen? What repeats? Okay, so can you repeat your finger or can you repeat the ring? Say for example, okay, let's understand the difference between the two, 5 power 3 and 3 power 5. Okay, 5 power 3 basically means 5 into 5 into 5. Okay, 3 power 5 means 3 into 3 into 3 into 3 into 3. Again, which one is true? Like, which one is correct? What do I do? So 5 into 5 into 5 means for the first finger, you have 5 options. Say I pick ring A. Okay. Now, for the second finger, again you are saying you have 5 options, but you don't. Ring A you have already won on first finger. So where is ring A again available? Right? See, this into means it is all happening at the same time. Right? What does this into mean? That I want this and this and this. So if you have won, say, ring A, first of all, you don't have ring A as an option again. So there itself this is wrong. Say you pick another ring. Say you tell me that okay, I don't want to pick ring A, what if I pick ring B? Fine. For third finger, again you are thinking 5 options. Say you pick ring C. 5 means from 5 I am taking 1. What about ring D and E? You are not going to wear them? Right? So that is why this is wrong. Okay, this is wrong, because if you are saying that okay, I have the 3 fingers and I will wear any of the 5 rings, then you will put one ring here, because 5 options means from 5 you are taking 1. So one will go here, one will go here, one will go here. What about the other 2 rings? Right? So remember, it's not 5 to the power 3 because the fingers are the ones that are repeating. Rings are not repeating. You can't repeat the same ring here and here. Okay, once you have won, say, ring A here in the index finger, you can't repeat it. What you can repeat instead is the finger. Okay, what you can repeat instead is the finger. What does that mean? That see, I will look at ring A. Okay, I will look at ring A and I will say I have 3 options. Wear it anywhere I want. Then I will look at ring B. Again, wear it in any of the fingers I want. So if I put ring A here, I can put ring B again here. Okay, I can repeat the finger. I can't repeat the ring. Similarly, ring C, ring D, ring E. So if you think about it, see, now I have compulsorily worn all the rings. Okay, I have worn all the rings compulsorily because ring A, I have 3 options. Wear it in any one of the 3. Ring B, again any one of the 3. Ring C, again any. So this way I am ensuring that I am wearing all the 5 rings. Okay, see, it's a very easy question. We all get confused here. Okay, so remember, understand what is it that can repeat. Okay, what is it that can repeat? In this case, the fingers can repeat. You can wear multiple rings on the same finger. So the ring is not repeating, the finger is repeating. Okay, so go for rings, make spaces for rings. Okay, make your 5 spaces for rings and then repeat your fingers. Hence, the answer here has to be 3 power 5 and not 5 power 3. Okay. So if you have understood the previous one, you should be able to solve this. 6 letters, 4 letter boxes. Again, 6 to the power 4 or 4 to the power 6. Again, take your time and think what can repeat. Can the same letter be given to multiple drop boxes, or can multiple letters be given to the same letter box? Right? Again, think. So see, again, it's the letter box that can repeat. Right? It's the same ring and finger question. It's the letter box that repeats, because letter box number A can have 2 letters, 3 letters, 4 letters, or all 6 letters. But the same letter cannot be given to 2 letter boxes. Right? So it's the letter box that repeat. So I will write letter A, letter B, letter C, letter D, letter E, letter F. Right? I have 4 options for letter A, then 4 for letter B, 4 for C, 4 for D, 4 for E, 4 for F. Okay, we can repeat the letters Okay, sorry, we can repeat the letter boxes, we can't repeat the letters. So I will simply, what will I do? I'll see, okay, this is letter A. Which box do I want to give it to? One of the four, send them. Letter B, again pick one of the boxes, give it. Letter C, again one of the four boxes, and so on. Okay, so remember, it's the letter boxes that can repeat, the letters can't repeat. Alright, so that's 4 raised to 6, that's 16, that's 4096. Moving on to the next one. So you have 4 different colors. You want to paint a fence with 7 vertical sections. No 2 adjacent sections have same color. Now the question itself says the color can be used multiple times, so you know repetition is allowed. Since repetition is allowed, don't think of permutation combination, directly think of counting. I want 7 vertical sections and I want all of them at once. So I want color here and a color here and a color here and here and here and here. So multiplication, right? Now for the first section, I have 4 options. Pick any color. Say for example, I pick the color yellow. Alright. Now the adjacent section has to be of a different color. So other than yellow, I have 3 options. Say I pick green. The next one cannot have green, can have anything else, right? So again 3 options because the yellow can repeat now. So like this, I will have 3 options every time because whatever color has been chosen the previous time cannot repeat. So simple, we have 4 into 3 power 6 options. Alright guys, I hope you understand the method of counting. Okay, remember there is a difference. Okay, a lot of overlap happens, but it is on us that we segregate them into 3 simple parts so that we never get confused. Okay, so that we never get confused. Remember, counting, whenever repetition is allowed, use counting. No need to think about permutation combination. Right? Now, if you understand this, so today we have covered the concept of counting. We still have permutation and combination to go. We'll study them in the next 2 parts. Okay, I hope I was able to make this topic easy to understand for you. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.